Welcome back to the data representation topic of our computer systems unit. In today's lesson we will find out how the computer stores and represents graphics. Specifically how they store and represent vector graphics and bitmap graphics. As always, we have some learning intentions which you can see on the screen now. As always, we have some success criteria which should be used as a tool to assess your progress with the lesson. Let's start off the lesson by looking at bitmap graphics and how bitmap graphics are represented in binary using the bitmap format. A bitmap graphic is represented using a grid or 2D array of pixels. Each individual pixel is allocated a binary value. The number of bits that we allocate to each pixel will determine the colours and shades of grey that it can represent. In the example we see here, we have a monochrome graphic. Each pixel has a binary value of a 0 or a 1. A 0 would represent a white pixel and a black pixel would be represented by the binary value 1. With coloured graphics this changes slightly. Normally for a photograph we would allocate 24 bits per pixel. This is called true colour. This will allow us to represent over 16 million colours and shades of grey per pixel. This is known as the bit depth of the pixel. This particular bitmap image is 8 pixels by 8 pixels. We are allocating 1 bit per pixel, and therefore this image requires 64 bits or 8 bytes of storage. If this image contained colour, we would therefore allocate additional bits per pixel. If it was true colour, 24 bit, the calculation would differ. We would have 64 pixels times 24 bits. This is a significant increase in storage for this graphic. This diagram shows the same example, only it shows the bitmap of the graphic. Within the grid we see the binary values. A 0 representing a white pixel and a 1 representing a black pixel. The second type of graphic we will talk about today are vector graphics. Vector graphics are stored differently from bitmap graphics. Vector graphics are stored as a list of attributes that describe to the computer how to redraw the objects that make up the image. The common vector objects you need to know about are rectangles, ellipse, line, and polygon. Now let's look at the objects and their associated attributes. Let's start with the ellipse. An ellipse would have coordinates, XY coordinates, a line colour, a fill colour, and possibly a fill pattern. This ellipse would be represented using coordinate points, a line colour of orange, and a fill colour of yellow. It's worth noting that further attributes would be involved in drawing this vector. The rectangle would have attributes such as coordinate points for the corners of the rectangle, a line colour, a line style, is it a solid line or a dashed line, line thickness, a fill colour, and perhaps a fill pattern. A line object would have attributes of a start and end coordinate points, a line colour, a line style, again a solid or dashed line, line thickness. The line is quite unique. It will not have any fill properties. And finally, a polygon. Its attributes would be coordinate points for its corners, line colour, line style, again solid or dashed, line thickness, a fill colour, and a fill pattern. You will have noticed that some of these objects have the same attributes. We can scale these objects up using their coordinate points, and similarly we can scale them down using the coordinate points too. Vectors have certain characteristics. They can be scaled up without loss of quality. That means they're resolution independent. We can layer objects on top of each other. We can also change an attribute of an object without impacting on the rest of the image or the other objects in the image. And they are relatively small in file size in comparison to bitmaps. The characteristics of a bitmap will be different. In a bitmap, each pixel can be edited to pixel level. Every pixel in a bitmap is saved. The file sizes of bitmaps are larger in comparison to vector graphics. And it's important to note a blank image will have the same file size as the image you see in this diagram, or an even more complex image. That's because we save every single pixel. Now let's look at how making changes to a bitmap file can impact on the file size. If we want to add extra detail to a bitmap image, we can change the pixels. Every pixel in a bitmap has already been saved. Therefore, changes we make to the bitmap image have no impact on the file size. Now let's look at vector graphics. We can add extra detail to a vector image by adding objects to the image. These objects are layered, as you can see in the diagram. Changes to a vector image by adding objects will increase the file size of the vector graphic. Thanks for listening. Please subscribe to our YouTube channel and hit the notification button for the most up-to-date content.